Hi there and welcome to the video. Okay, so let's have a quick look at this question about projectiles. It tells you that particle P moves freely under gravity in a plane fixed at OX, which lies on the horizontal ground and fixed horizontal axis OY. P is projected from O with the velocity components OX, OY in U and V respectively. P returns to the ground at C. Determine in terms of U, V, G the distance OC. Okay, so what we know that this is going in this direction, so I'm going to call so always call them X and Y components, and U is the initial velocity of X. The X direction is going to be capital U. Now the letters they use is a bit confusing because you associate with U with final initial velocity and V with final velocity, but just trying to keep these footnotes to keep you right. So U of Y is going to be capital V. Okay, so try not to get confused with those. So they've been a bit naughty with that. Okay, so what do we know? We know that this is O to C, and displacement O to C is going to equal, so S equals O to C is going to be U multiplied by T, which is the time. So we need to find the time it takes from going from there to there. So what can we do here? We've got a bit more information about what's happening vertically. So that's done here so far. So what's happening vertically, we've got a couple of components at play. We know that displacement, it starts from 0 and it's going to go back to 0. So we know that displacement is going to be 0. We also know that acceleration is going to be just gravity acting on that particle P, so it's going to be minus G. And what else do we know? Well, we know that the initial velocity is V, and we need to find what is T. So when we got U, S, T, A, we can use the formula. I'm just going to write it here. A very important formula. S equals UT plus half A T squared. Now I'm going to put Y there because that's the, and this displacement is in terms of Y, the horizontal. So what do we know? We know that that is 0. Okay, so we can say, and the initial velocity is capital V multiplied by T. Acceleration is minus G, so that's going to be minus a half G T squared. Okay, now we've got two values of T, obviously because T starts from 0 and then it comes back after so many seconds. So let's just factorize that, take the T out. So we know that component T is going to be 0. We need to find the second time is going to be hitting the ground, GT. And if we set that, rearrange that, so we know that V minus half GT is going to equal 0. Take that to the other side. V is equal to half GT, and therefore T is going to equal, so if we times that by 2 and divide it by T, you get 2V over G. So once we know that time, we can go back here and find out OC is going to equal U, and there's the time, 2V over G, and then I'm going to get my answer to be, that's going to be 2UV over G. So that is this one done. Okay, I've done that one. So that is OC. Okay, so let's just line this up. Doesn't interfere with the other parts. Actually, if I use, so that was part A. So that's A there done. So let's go on to B now. Now, if we look at B, so here it goes, P passes through 2 points, A and B, each have a height of H above the ground and distance D apart, as shown. Write down the horizontal and vertical components. Okay, so if we're going there, we need to find the vertical components of this, which is velocity in terms of horizontal and vertical. Well, we know that the velocity doesn't change in the horizontal. Okay, so we know that the final velocity in terms of x is always going to be the same as the initial velocity, which is in this case capital U. Now we're looking at the vertical component, so we want to know the final velocity of y at that point. Okay, so what do we know? We know that the s is h, so that's the displacement. We know that, we always know that, just give me 1 second, across from there. We also know that, sorry about that, a, the acceleration is always going to be minus g, okay, the gravity acting on it. So we got that, we need to find the final. And we know that the initial velocity, which was given to us, u of y is capital V. Okay, now if you're using that, if you got a, u, v and s, then you should use this formula, which is v squared minus u squared equals 2as. And if you rearrange that, so you get v squared equals u squared plus 2as. Okay, so we know, we know that the final velocity at point A is going to equal to, so the initial velocity was capital V, so that's going to be capital V squared minus, because that's minus, it becomes a minus g, so that's going to be take away 2g, and s is h in this case. So therefore, the y component's there. Okay, the vertical component, actually, let me just take that off. So the y component just going to be the root of that, so that's capital V minus 2gh square rooted. So we got that. So that's going to be v squared minus 2gh square root. Okay, so that one's done. Okay, let's just line this up. Just worried about the space, running out of space. So let's have a look at C now. So it goes, hence determine an expression in terms of D, expression for D in terms of U, V, G, and H. So we need to find that. Now, if you look at this closely, what you got is, if you take that distance D going from there to there, this is H, this is H, this is, you can see, we can treat this as a small projectile question here, going from there to there. So we can do the same thing here and apply it to this projection here, because that also follows the projection, and set that as to be ground level. The reason why I'm saying that, because we already know from A, by doing this question, that these are the initial velocities at A, and then it will come back to B, okay, where that displacement, if we start that displacement to be 0, then it will come back to 0 here. So we can apply this same rule to here with these new components. Okay, let's try that then. So let's have a go. So we've done that. I'm going to change the color so it doesn't interfere with us. So this is C. So what do we know? We know that we're going to set the initial velocity here. Now the initial velocity does not change. It's always u. So the u of x component is going to be u, and the vertical component is going to be this one, which is v squared minus 2gh square root. Okay, so we got those components. In this one, we know that the distance from when it goes up and comes back down to that level is going to be d. So we know the displacement is d. So there's the displacement formula here. So if we say that s, which is now d, so d is going to equal this u multiplied by t. And if we rearrange that, we then get t is equal to d divided by u. Okay, that's the capital U. Sorry, it's just so that's a big U, capital U. Okay, now since we know that, we can then use this formula, what we used earlier on, okay, and work out what the so we know from here that this is the final velocity, this is the time, but we know that the time is going to be t. So let's have a look. Yeah, so let's just use this formula. So your initial velocity is this. So I'm going to use this. So you've got two components. You can got t equals 0 here, or you got v, which is the initial velocity in this case. So let's just write that down here. I'm going to write that in red so it doesn't. So we know that from this component, if you make that equal to 0, you know that time is either 0 there, or when that initial velocity minus half gt is equal to 0. Okay, or if that's confused you, let's just do it all from scratch. Yeah, let's just do it all from scratch. Let's just, because that might confuse you. So I'll put a line there. It's just with the space, that's why. Okay, so let's just say we know that these are the components, and we know that S, we're going to use the formula S equals ut plus half at squared, and we know that our this is going to be 0, because we're going to go from there to there, come back on itself, and we know that t, we can factorize the t, and we've got initial velocity plus half a t. So we know either that is going to equal to 0, which it is when it starts there, or we know that the initial velocity plus half at is going to equal to 0, which is, this is initial velocity. So I'm going to put that, I'm going to plug this in here now, so just be careful here. So we got v squared minus 2gh square rooted. Now this plus becomes a minus because that's going to be minus g, so that's going to be minus half g, and the t, we know that the t is d over u, and that's going to equal 0. So if I take that, rearrange this and put that on the other side, I'll get, so that's going to go there. So you know that half g d all over u is going to equal v squared minus g 2gh all rooted. Now if I times that up by u, so the u is going to go up, the 2 is going to go up, and the g is going down, you've got d, the subject. So I'm just going to rewrite that again, so and put it around the box. So d is going to equal 2u over g multiplied by v squared minus 2gh. Put a box around that. That's that one done. Okay, so we got d in terms of u, v, g, h. Okay, let's just line this up. And let's do the last part. So it goes here, given that direction of motion p as it passes through A is inclined to the horizontal to angle theta, angle theta, where tan theta is a half, determine expression for v in terms of g, d and h. So if we look at here, okay, what it's telling me, actually I'm going to change the color here. So you've got this projection here going that way. That is the theta. Now you should know that tan theta is the opposite, which in this case is going to be v pi over the adjacent, which is v of x. Okay, so that's what it is. So that divided by that is going to equal a half. So it tells you that in the question. So we know that we already worked these out from here. So the velocity at A from here is going to be that. So I'm going to write it down here. So we got v squared minus 2gh all square rooted over the velocity of the x component is u, and that is going to equal half. Okay, so if I times that up and times that up, I've got 2 v squared minus 2gh square rooted is going to equal to u. Now we've got this in terms of u, but we want to put it in terms of gdh. So we need to rearrange. Where have we got d in terms of u? Here we got it. So if we can rearrange this to make u the subject and put it in here, and then we can try to get that v in terms of gdh. Okay, so let's just do this. I'm going to multiply that up and multiply that up and divide it by 2 and this root. So I know that u is equal to, multiply that up, so that's going to give me g d, so times that up, and I'm going to times so times the g up, we'll divide it by that and that, so that's going to be divided by 2 and this v squared minus 2gh. Okay, just put a box around there. So obviously I'm running out of place, so I'm missing some steps here. So all I've done is g times the d, and then taken the 2 underneath with this bracket underneath, which is being multiplied all down to get u the subject. So now I know that is equal to that. So let's just rewrite this. So that is 2 v squared minus 2gh all rooted is equal to g d over 2 v squared minus 2gh all square rooted. Now that looks okay, that, because when I times that up by that, that square root is going to disappear. So let's just let's just times that up. So that's going to give me 4 in brackets v squared minus 2gh, and that's going to equal dg. Okay, just rearrange them that way in capital order. So now I'm going to rearrange it to make v the subject. So I'm going to divide that by 4 and take this over. So v squared is going to equal dg divided by 4 plus this over 2gh. Okay, so I'm going to factorize that. So that's going to give me v squared is going to give me, I'm going to take a factor of 4 out, and I'm going to take a factor of right, okay, let's just take this g in there. So if I then close that and get the g out, I've got the d there, and because I took 4 out, I need to times that by 4, so that's going to give me 8h. So let's just think about this. So we took a quarter out, so, and we took the g out there. So by taking a quarter out, I need to take that quarter times 8 is going to give me 2, times by g and h is going to give me back to that 2gh, and we've got a quarter of dg. Excellent. So now if we want v, we just square root everything on your right. Square root of a quarter is a half, and we square root all that. So we've got g brackets d plus 8h square rooted, and that's it. Okay, so yeah, it's a bit tricky. I was more worried about trying to get it all fitted in, so that's that one done. The tricky part here is because they use u and v as your initial, and we refer to u as your initial and v as your final velocity. But just be careful with that. And other than that, and also they use this tan theta, just remember that's just opposite of adjacent, so that's the same as that. Okay, other than those tricky parts, really once you've done these two, A and B, you can do C and D in a similar way. It's just the algebra rearrangement that's a bit confusing at times, so you just got to be careful, okay, just because of the letters they've used. Alright, a bit naughty here, but okay, thanks for watching, see you, bye bye.